Hello everyone and welcome back to Fun Mathology. Today's topic is a 8-second trick to find out whether a large number is prime or composite. Now see, I have written a number 7919. The question is it a prime or a composite? Now to find out, looks very scary, right? But I'll show you, do not worry. A quick tricks to check if a big number is primary or composite without going crazy dividing by each number. Okay, it's a lengthy process, right? If you have a big number. If it's a small number, then it's an easy process. Now let's recap what we have learned in earlier lectures. What are prime numbers and composite numbers, and slowly we will get into the trick. Okay, so what is a prime number? So we know a prime number has only two factors. That is 1 and itself. So if you have seen my previous lectures, and also you know that a prime number has only two factors, 1 and itself. Now what is a composite number? Which has more than two factors. So this is the basic difference. Now we have seen in earlier lectures how to, do not worry, I'll show you step by step the trick to test the primality, even if the number is large and larger than this also. Okay, but let us go step by step. Okay. See the method 1, right? Quick divisibility rules. Now in earlier lectures I have shown you. So what are quick divisibility rules? Now if it is a small number, right? Now use this rule for small numbers. Right? For small numbers. Like divisibility rules means you have to check the divisibility by 2, divisibility by 2, by 3, by 5, by 11 and so on. So we have learned what are the basic concept behind how to check a number whether it is divisible by 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So let's say if you get a number like 29, so you can easily check it whether it is divisible by 2 or not. So it is not divisible by 2. So if you add this number, it is the 9 plus 2 is 11. So 11 is not divisible by 3. So the entire number is not divisible by 3. So it is not divisible by 4 either. It doesn't end in 5 or 0. So it is not divisible by 5. It is also not divisible by 7. It is also not divisible by 11. So we can say this as a prime number. So if a number is small, we can quickly say whether it's a prime number or not by quick divisibility rules, as you have learned before. Now we have also learned what? This one, I guess you remember, sieve of Eratosthenes. So if you have forgotten, please go and check my earlier video on sieve of Eratosthenes. Now by using sieve of Eratosthenes, we can find out the list of prime numbers from 1 to 100. Okay, maybe 1 to 200. So for a smaller scale, we can use sieve of Eratosthenes easily. But if the number is large, we will not be able to use quick divisibility rules or sieve of Eratosthenes. Let's move to the method number 2. Now this is known as square root rule. Now what does it say? This rule says to test the primality, you need to check divisibility up to square root of n, where n is the given number. Now what is a square root? A square root of a number is a value that when multiplied by itself result in its original number. For example, square root of, this is the sign of square root of 25 is 5. It means if I multiply 5 by itself 5, I'll reach 25. Got it? So the square root of 25 is 5. Now I can use this square root rule. See, if I have this number, gigantic number 7919, right? 7919. If I go and find out the square root of 7919, it comes to approximately 89. Now I can go and check all the primes. Check all the primes less than 89 only. So it reduces the effort. So I can check whether it is divisible by 2, 3, 5, 7, 11, 13 and all the prime numbers till 89. So if we check it carefully, we'll see that none of them can exactly divide 7919, and hence we can say that 7919 is a prime number, Got it? Now we have seen what? So we have seen few tests. If the number is small or if the number is little big. Which one? The first one is quick divisibility rules for very small numbers and siva Viratosthenes. We have seen in method 2 square root rule by finding out the square root and check all the primes till the square root number. If the number is not divisible by all the primes till the square root number, we can say that it is a prime number. Now let's come to the main point, the main aspect. The 8-second trick for testing the primes. So let's go by step, then we'll do it in 8 seconds. So for testing the primes, see, we'll use this 6n plus 1 or we'll use 6n minus 1 where n is a natural number. This rule says that every prime numbers greater than 3. Okay, the primary condition, the prime number has to be greater than 3. So this rule says that every prime numbers greater than 3 must be in the form of either 6n plus 1 or 6n minus 1 where n is a natural number. So if a given number can be represented either in this form or in this form, we can say that particular number is a prime number. Got it? We have to remember two things here. If a number is prime, it must be in the form of either this or this, but the reverse is not true. That is, all the numbers in the form of 6n plus 1 or 6n minus 1 are primes. It is not always true. Let's say 6 into 4 plus 1, right? So 6n plus 1. So let's say I take n as 4. 6 into 4 plus 1 is how much? 25. Now 25 is not a prime. It is a composite. So the reverse is not true. But if a number is prime, it must be in the form of either this or this. Let's say I have a number 6113. Got it? So I have a number 6113. So if I write, so as we know, the rule says it can be represented, let's say this is a prime. So it can be represented in this form. So we'll write 6n plus 1 is equal to 6113, or 6n is 6113 minus 1, which results to 6112, or n is 6112 divided by 6, which results in 1017. See, 1017, n is a natural number, so it is proved. So we can straight away say that 6113 is a prime number, right? Now, let's say we'll take another number, right? We take another number. This is a big number. Got it? So this is also a big number. Now, somebody asks you, or you are requested to tell whether this particular given number is a prime or not, is a prime or a composite. So let's start counting 8 seconds from now. So we'll write 6n plus 1 is equal to 55351, or 6n 55351 minus 1 is 55350, or n is 55350 by 6, which gives you 9225. Voila. See, this is a natural number, so we can say this is a prime number. Got it? So this is a prime number. This is also a prime number, right? This is also a prime number. So using this 8-second trick, you can find out whether a given number is a prime or not. Got it? So at the end of this video, we have come to the end of the video. I'll give you a question. Okay? Let me know by following this trick. Let me know 999983. Is this a prime? Is this a prime or composite? Let me know, student, in the comment box whether this is a prime or a composite. Got it? So now you know how to test it. Test if a number is a prime or not in 8 seconds. Okay? Okay, students. Thanks for watching. Have a great day. We'll soon meet. Bye bye.